Good morning, everybody. My name is Daniel Lay. I'm with CA Technologies, and I'm responsible for our capacity management and performance engineering products in North America. I appreciate the time to spend with you this morning, and just want to put a little context on. Can't hear me. Okay, is this any better? Okay, I'll stay very close to the microphone. So the title, in terms of what was put on the agenda, was a little bit vague. So I want to just set some expectations as to what we're talking about here. And what I'll be presenting about this morning is some obstacles we're seeing to migration to cloud, and some of the processes, tools, and techniques we're seeing used in the marketplace to help through that. So that's going to be the primary focus of the conversation, if you will. In order to do that, the other part of it is what some of the industry dynamics that I wanted to share with you, and share some perspectives in terms of what we're hearing across the field, both public and private sectors, as this kind of technology gets adopted. So those are the that's really what this will be about, and just want to make sure that we clarify that, since we had a bit of a fluffy title for the presentation. So here's the net of it. You look at the recent headlines in the space, and government is being put in cloud, or certain government IT functions are being put in cloud. The headlines are constant and continuous, and the fact is a number of services are being put up in cloud for public sector kind of applications. And what that means different things to different people. So part of it is I want to make sure that we reset in terms of what cloud is and what it means to roll out applications into the cloud. But the net of it is the buzz is there, the headlines are there, the initiatives are there to start moving applications into this cloud. So what does that mean? Well, I walked into the tail end of the presentation of the prior presenter, but there's a lot of promise in this technology. It's really just another delivery method, but it gives you some capabilities that may or may not be present in your current state, right? The ability to consume increase demand consumption rapidly, some agility, CapEx versus OpEx advantages, right? The ability to pay as you go is the theory behind this. Being able to use IT assets more efficiently, being able to shift resources to focus on what in theory is the key strengths of each part of the IT organization, right? So if you're responsible for a particular service or particular app to deliver, focus on that and not necessarily on the utility computing is the theory, right? As we go through this presentation, though, and just by a quick show of hands, because I'm prepared to talk about this from the context of a cloud consumer of services, as well as from a cloud provider. And the challenges are a little bit different, although there's a lot of commonality. So just by show of hands, how many of you are standing up a cloud, almost like a cloud provider, if you will? All right, thank you. And how many of you are looking to consume cloud as utility computing here? Interesting mix, but we have more consumers than we have providers, which is not atypical, right? But I'll make sure that I touch upon this from both perspectives, because I think it's important from both a consumer perspective to understand the challenges that your providers are encountering, and at the same time from a provider perspective, some of the things that we're seeing in the space. So you've all seen these charts, and this is more of a matter of a reset, so for a common reference model. But if you look at the NIST definition of a cloud, it has certain characteristics, right? It has some service models and it has some deployment models. In the end, it's about self-service. It's about being able to deploy either to private, hybrid, public, or community clouds, and you've got multiple flavors, right? Platform as a service, infrastructure as a service, software as a service. So all this stuff, if you will, is being lumped together as cloud, and it means different things to different people. So I just want to make sure that we set that up as a common reference point for the discussion. And likewise, then in this reference, there's also these different players, right? You've got your subscribers or consumers. The majority of you held your hand up that way. You've got your providers. Then you've got the technology enablers, and you've got an emerging part of the business in the brokerage, right? there's a lot of buzz right now in the marketplace around cloud brokers, especially as entities try to exploit and use public cloud more and more. How do I know that whether I want Verizon Terramark or Amazon EC2 or whatever else? And I see it more prevalent in the private sector, but in certain places you see individuals, app owners or developers, et cetera, making decisions and going out and purchasing capacity, completely outside of the framework of an IT organization, right? If you could spend a couple $100 a month on your corporate credit card, go buy it, and it falls completely out of governance, completely out of security practice, et cetera. So there's this brokerage concept as well about trying to add some governance to the whole picture. So that's sort of the dynamics that we're seeing out there. Obviously, I'm with CA. We're, in essence, on the enabler side because we really provide management tools. So I'll try to provide a unbiased view of what we're seeing out there in terms of the enablement side of the house. That's the space I come from, but that's the goal today. So from that perspective, the promise is all there, but at the same time, there's a lot of obstacles to adoption. The biggest obstacle we're seeing to adoption out there is risk, whether it's real or perceived. From an end user's perspective, there's a lot of people uncomfortable with moving their apps to the cloud, right? So people want to understand, how secure will my data be? Will I have to compromise on performance? What are the service levels I should expect? If things go wrong, how easy is it or how hard is it to turn back? If I'm building up a private cloud, what does it mean in terms of all this infrastructure I already have in place? I've spent tens of millions, if not hundreds of millions of dollars standing all this stuff up. What happens to it? Can I still use it, et cetera? And as we talk about cloud, we all get the fact that there's this self-service portal and you want to request some capabilities. For the most part, it seems to be utility computing, but in government and in large enterprise IT, the reality is that cloud can't be called the one-size-fits-all kind of solution, if you will. A lot of cloud providers are building their clouds, and rightfully so, in terms of this utility compute model around these sort of current virtualization platforms, right? Yes, things like VMware, or Azure, et cetera, right? But the fact is two things happen. From an end user perspective, we do see the desire to have this self-service capability, to have the customers and your end users drive more of what they need and request. Have a real approval cycle there, back to this governance and brokerage and making sure that people are not going out of compliance and putting the organization at risk. And also at the same time, that automation piece to two things, create some internal approvals. There was a question in the earlier session, somebody was asking about capacity, right? How do I know if the cloud provider is going to have enough capacity? And then from an end user perspective, how much do I know, how do I know how much do I need to buy, right? If I'm going to go buy some Amazon EC2 slots, do I need do I need to buy the large, medium, or small compute unit, and how many do I need? So the idea here is to have somebody in that loop that also understands the capacity, whether it's for private cloud or am I buying the right stuff on the public cloud? And in the end, to ensure that you're driving some standards and standard configurations from an organizational perspective, right? These are my processes. These are my approved, platforms, templates, whatever you want to call them, right? How do you define as an organization what it is that you're willing to put out there, and that way you can manage cost, performance, et cetera? Because just something to think about as you're looking at that. And as I said, I will try my best to keep the commercials to the minimum, but that's really, as a consumer of these services, what I would be looking for. Capturing consumption, show back, charge back, obviously is a big part of the model, right? And the people in this room probably know that better than anybody else in terms of what the different departments and agencies, et cetera, are looking to. Your end users are asking for that today. So that's the vision. That's what a government cloud could look like. But one of the things I wanted to put forth is really the fact that it tends to be heterogeneous. It's not going to be, Verizon Terramark or AT&T or Amazon EC2 or Rackspace can solve all my cloud issues, right? And in fact, what I wanted to do next is share with you the results of a survey that just came out actually middle of this month. So this is very recent data. IDC put out a survey, if you will, asking people what their spending priorities would be in cloud, what they have been over the past 18 months, and what they will be over the next 36. The results were just released, less than a week ago. And what I found really interesting, just because I'm from the space, right, is that capacity and performance analytics are flowing up to the forefront. They're using, obviously, everybody's heard about the fact that people are using cloud as a catalyst to streamline and make more efficient. But the people that have already rolled out certain cloud functionality are running into some barriers, if you will, is what we're hearing out in the marketplace. They initially focused on that self-service portal and the auto-provisioning, right? So the infrastructure piece that you're mentioning. So everybody had that sort of licked, if you will, and they went down that path. The problem that is being encountered is that all of a sudden, everybody thought, that's it, we're in the cloud, and they're encountering some performance issues, they're encountering barriers to migration and to onboarding. And at the same time, they're getting pushback from the business or from the purse strings in terms of saying, well, you're already there, you've outsourced, you're using this, third party managing your cloud. Why do you still need to spend money on management? And the reality is that the management headaches don't go away. If anything, they get more complex because now your workloads, your apps, your services are running in something that you don't necessarily have full control of, right? So as a consumer of cloud services, you've got that challenge. As a provider of cloud services, we're seeing the other side of the fence, which is the vendors the cloud providers want people to get onboarded, but they're having a hard time showing their potential customers how their workloads, how their applications will perform on those clouds. So that's really where we're seeing a little bit of that dichotomy. So in that context, what I found interesting was the following. Here's where we see the investments. And this is interesting because if you look at it, 27% plus 18.9%, close to 50% of the organizations are basically trying to build a private cloud. So back to that question about how do I leverage the investments I already made, it's really about shifting the delivery paradigm, right? But still using that infrastructure to build a private cloud. The third one here is starting to use public, and the rest is sort of fragmented. But if you look at it, over 50% is really about building private clouds. There's not a lot of comfort yet in going to purely public clouds, except for certain key services, right? The headlines that I showed earlier, right? People will do it for email services and for cloud-based storage, et cetera. But you're not seeing a lot of mission-critical apps go to that public cloud yet, or places where you're going to hold people's social security numbers or personal information, et cetera. So I wanted to share that, as well as the fact that if you look at the spend in the last 18 months, has shifted versus a prior period to spend more money on capacity planning and analytics and less on the provisioning and workload moving hooks, if you will. And that's sort of looking back 18 months. Looking forward to the next 36 months, same thing. It's really about capacity planning and analytics, server management tools, so back to managing that virtual infrastructure. And the third one is application performance management. So what that's telling us, right, and it validated, to me that was interesting because it validated what we're seeing empirically with 200 plus IT leaders across business and government responding that it's really about the applications and the payloads, right? It's not an infrastructure question, it's not a provisioning question, it's about how are these payloads performing or how are these payloads going to perform. So that's what I wanted to share in the context of that, because that's the biggest challenge to adoption that we're seeing out there is how will my stuff perform there? And I see some heads nodding, so we're validating our data. This is all happening real time, if you will, but also wanted to share what we're seeing out there with you. So The challenges that we see on the cloud provider side, right, is while facing their customers, is really about onboarding people, right? When I onboard people to my cloud, how do I help you as my customer understand how my workloads are going to perform there? You know, what will be the response time? What will be, you know, am I selling you too much, not enough of this capacity, if you will? And also, you know, I don't want to fail. I want to identify the right applications and the right workloads to bring onto the cloud, right? You know, we all understand there's some mandates that say, you know, bring everything over, but the fact is some architectures may not be ready, right? So, you know, does the cloud provider have the wherewithal and the tools and analytics to say, hey, these workloads will make perfect sense. These other ones, you know, keep as is. And so that's what their challenges we're seeing customer facing. And internally, it's really, you know, you heard the gentleman from AT&T, if you're in the prior discussion here, basically said, you know, as much as to the end user, the cloud appears as this completely elastic, infinite set of resources. The reality is there's a whole bunch of people in the background going, oh, darn, we need more servers, or, you know, how do I pack more VMs into this cluster, et cetera. So they need the tools to get that visibility in the context of the services that are being delivered and in the context of, you know, how those workloads are actually using assets. As mentioned earlier, the infrastructure part is kind of licked, but the problem is how do you know if there's going to be, you know, contention going to the SAN versus network versus memory versus CPU bound things? And unless you understand really what the payloads are doing, all that is really being provided is utility-based computing. And then the question is who's responsible really for understanding whether those payloads are going to perform and what service levels you can sign up for. And part of the problem that we're seeing in public cloud is that there's no real standards for service delivery. It's all availability, right? So they're selling you X number of vCPU cores or X number of compute cores and X number of RAM, and you know, 4 nines or 5 nines of availability. But what does that mean to you as a consumer of these products, right? So that's where we're seeing a lot of the challenges to adoption. Yes?
A new challenge that we're experiencing is the migration to the cloud, is providing application architectural or re-architecting applications that fit the cloud either more efficiently and to achieve some of these goals. So not just taking one for one.
Yep.
Right.
The bullet's right there.
Right.
Absolutely.
We're spend the time with the resources to be able to
exactly
do that, and that's not a simple task.
So that's sort of switching my hat from the cloud provider side of the equation to the cloud consumer part of the equation. You're absolutely right. You know, what do I migrate and what do I keep on other delivery architectures or re-architect because they're not cloud friendly, right? And when you know, how do I validate that the architectural changes I've made, A, have made it cloud friendly, and B, you know, where are my bottlenecks going to be? How do I analyze and study that so that I ensure a smooth transition? So absolutely, yeah, you're right on. We're seeing that as well. And if you're going to go to public cloud, there's a lot of confusion in the marketplace. There's a boatload of providers, quite frankly, and you know, they all say the messaging is rather similar from all of them. So how do you differentiate? You know, and how do I know what's really under the covers, or how do I get the metrics to understand how my payloads are going to, or my workloads are going to perform, right? And lastly, the other part of it is economics, right? Just like with physical assets, just like with what we saw with virtualization, you know, when we saw a lot of physical to virtual migration, right? If you're offering your customers 3 templates, right? A 2x4, a 4x8, and an 8x64 or whatever, everybody thinks their application is the biggest and the baddest, and they tend to buy the big one, right? It results in a lot of waste, and oftentimes, you know, not a lot of efficiency. So it's back to that. How do I right-size my workloads to whatever I'm buying? Make sense? So in that context, and back to trying to be, you know, vendor neutral here, right? What we're seeing out there is that there's a series of steps that people are trying to follow in a methodology for migration. And part of it is about characterizing the as-is environment, right? So how do I characterize an application that I'm delivering right now on physical infrastructure or on virtual infrastructure or on a mainframe or, you know, on AIX, LPARs, whatever? How do I characterize how it's working right now, what its throughput is, you know, how many users, what compute resources it's using it, so I can then map that to the to-be environment, whether it's public, private, et cetera. And one of the things that we're seeing out there is that there are tools that'll help you. The performance and application management tools have been out there for a long time. But the challenge that we're seeing is that either, from multiple organizations, unless you have a very homogeneous environment, right, where everything's nailed and instrumented, oftentimes to get the data that you need to analyze these things, you need to put new instrumentation out there, and that's counter to what people want to do. So the question really is, can I get the data in an agentless way, i.e. without having to lay new instrumentation from the tools I already have in place? And for the most part, what we're seeing out there is that the data is there to be had, right? People will have APM tools, be it CAs or CompuWares or some of the up-and-comers like an Optier, et cetera, but or internal Oracle tools that they have that give them what the session rate is and how many simultaneous users I'm supporting and those kind of things, right? So the question is, can I get to that data? And you also have all these system management tools that are telling you host resources, right? These processes make up application XYZ and they're consuming this much memory, this much CPU, this much I/O. So how do I leverage that without having to lay out new instrumentation? So one of the considerations or one of the requests we're seeing out there, both on the consumer side as well as on the provider side. The providers that are wanting to be consultative and say, this is how your payloads are going to perform, same thing. They don't want to have to reinvent, put something out there. Even more importantly, the historical data around the peaks becomes the critical piece, because we all know there's seasonality that's different for different applications, right? If you're running a welfare-related application, it's going to be at month end when people are collecting benefits, right? If you're related to tax collection, it's going to be around the January through April timeframe, et cetera. So everybody has different seasonal peaks, and what you want to do is capture those seasonal peaks to plan, right? Because you want to capture the profiles of those seasonal peaks to then plan how much resource it's going to consume and how this is going to behave. So it's really about gathering the historical data from the peaks to plan on how you move forward, and that becomes more and more critical. The other part of it is, so we're talking about using historical data to characterize the as-is environment. That data is then used to model the to-be state in the cloud, but not only do people care about modeling the current capacity and the peak consumption, but we're all encountering growth to some level, right? With here in the state, we're working with an agency where they've got the application rolled out to X number of counties, and that number is supposed to more than grow by tenfold over the next 13 months. So the historical data is not going to tell you what resources are going to be consumed when the workload demand grows by 10x. So that's part of it, is how can I actually support those nonlinear growth scenarios, especially if you change an architecture or if you have no context for how history occurred, right? So there's some need for some more sophisticated modeling, if you will. And as mentioned earlier, because of that picture of what a government cloud looks like, you need to support those heterogeneous environments to scale to very large environments, especially places like the state here, and focus above the infrastructure on the applications and services. So that's what we're hearing that people are wanting to do to get through this barrier for adoption, if you will. Make sense? How are we doing on time here? So what we're seeing then is an evolution of how people are managing this data and capacity and performance information and how they use it. And I wanted to share that as well. So from that perspective, and I'm trying to figure out where the laser pointer is. Here we go. Traditionally what we've seen out there is the ability to consume that resource and host resource utilization data is the first step. Adding on top of that, the ability to trend it by business service, if you will. So being able to profile those payloads and those workloads, especially in shared infrastructure, and then correlate that to resource usage. So all this is based on just analyzing that historical data in the environment, right? That present state. Now, there's a lot of ways to do that. There are a lot of tools in the marketplace that are performance tools that let you slice and dice data in multiple ways. So that's a problem that's been around for a while, and there's different ways to handle that. We've got some unique capabilities in the space, and then the performance analytics tools that are there to do historical analysis seem to satisfy that, and it's about tying processes around that for that snapshot. Where it gets a little bit more challenging, though, is that there is not a lot of broad-based available technology in terms of predicting future capacity needs, predicting bottlenecks if I change the architecture, as well as ensuring that I'm going to perform properly at the throughput and application service level. Everything tends to be very infrastructure focused. So this is where we believe that there's a lot of innovation needed. We've got some things in our portfolio, but in general, these are the kind of capabilities that we're seeing people use to get through that hump, if you will.
Do you often see that people skip those first 3 steps because when you build your cloud infrastructure, you tend to build in extra capacity and the ability to change the resources delivered. So you might give them 1 CPU and some little bit of memory, but tomorrow you can give them twice as much.
Well, it depends.
So
if I look at it as a cloud consumer, no. If I look at it as a cloud provider, the answer is yes. But then the disconnect I have is what these applications really consume. Are they going to consume, storage volume, i.e. lots of terabytes, or are going to consume storage I/O because it's a medical application and I'm moving, X-rays and MRIs that suck up a whole bunch of bandwidth on the SAN, for example, right? They don't have that level of view. So then you still, as a cloud provider, still don't know. Maybe you have all these resources, but if you put all those kind of applications on the same cluster, you're going to end up with service delivery issues where maybe you have to distribute those around multiple clusters in your cloud to be able to support different users with those profiles, right? Make sense?
Yeah.
So what we're saying there is, in essence, is that you've got, these technologies already in place that are managing your environment that are sort of like being able to look out the windshield and out the rearview mirror, right? So you've got the ability to look backwards and look at real time, most of us, as I understand it, have that capability to sort of have some situational awareness of what's going on historically and what's happening right now. The problem is that does not necessarily, because of all the dynamics we talk about, give you a good outlook to the future, right? And you end up with these kind of challenges. So the idea here is that not only to have that rear view mirror and that windshield view of my infrastructure, but really to have the GPS, if you will. And just conceptually speaking, the ability to say, hey, if I stay down my current path, then my response time for this application are going to be 1.02 seconds. And if I go down the cloud path, I'm going to get all these benefits, but keep in mind that my response times are going to increase by 25%. Is that okay or not? That may be perfectly adequate, right? But that may not be. So the idea is to have the data and the analytics to get these kind of answers and to have the GPS so that you know whether you're going to fall off the bridge because the road's under construction, or you have a path where you're going to stay good, if you will. So conceptually, that's what we're seeing people looking for, and there's places where that is being done rather successfully, right? And it's really around these areas, right? Planning for those initiatives or those changes, mitigating the risk to my quality of service, and at the same time, realizing those cost benefits of the cloud. So how does that done? Picture, if you will, the ability to bring data into these multiple analytics engines that have, for the most part, some modeling capabilities to consume performance data. That's what's going to give me my current state. I need to consume configuration data so I understand the horsepower of the platforms that I'm currently running on. So the analytics engines need to be able to compare these different platforms, to understand that if I compare a Dell XYZ or an R600 with an HP Blade system with an IBM P series, that I understand, relatively speaking, how much resources these are going to consume. So then I can normalize that data and move it to the cloud, right? Or move it to whatever my to-be environment is going to be. In order to do that, I need to consume configuration data to automate that. Otherwise, it's really, really manual and really, really painful. So the configuration data gives you the service level association, ideally in environments where you have CMDB and asset management systems, but it also gives you the config of those assets. So now I know whether this workload is running on a little machine that has this much horsepower or on a big machine that has that much horsepower and how much resource I'm going to consume. Otherwise, traditional management tools just say, you're using 30% of memory and 40% of CPU. Well, relative to what? If I have a $3,000 box and a $40,000 box, and one's used at 50%, one's used at 20%, I really can't say that my average is 30%, because it's not fair to say that, right? So it's about that normalization. And the third leg of that, and this is why just trending doesn't work, is to bring in those business growth plans, right? I'm gonna onboard 300 counties to this application this year. What does that mean? And in the end, what people want then is, how efficiently am I using my stuff today? What are my best actions to ensure that I'm going to be okay right now? And some of the cloud providers are doing that in terms of how many customers am I onboarding this month, this quarter? Do I have enough headroom without having to overbuy? And the plans for success in terms of architecture, platform choices, cloud provider choices, etc.
So like in the past, we over-provisioned our applications to get our performance, but with a business driver in the cloud to reduce costs, you can't over-provision everything.
Well, even in the physical or virtual space where you run your own infrastructure, you're absolutely right. And the evidence of that is that the average, Gartner will tell you that the average data center utilization for resources is 20%. We're getting feedback that in cloud environments, up to 30% of the VMs go underutilized or unutilized. Especially, there was a comment made earlier about agile development. Agile development is notorious for a whole bunch of users going and requesting a whole bunch of VMs and instances, doing whatever they need to do, and then never tearing them down, right? All of a sudden, you have all these reserved assets that never get freed up for anything else. So that's sort of the 10,000-foot view. What I wanted to just create a little bit of vision for is, what does the data look like? Show me what people are actually seeing when you describe this thing. So I've got some sample outputs to walk you through some of the scenarios that people are going through with this kind of technology, to use predictive analytics, if you will, to drive this decision support. So that's what I have, a few sample graphs, and then we'll wind down for Q&A. So before I show the details of the sample graphs, I wanted to talk a little bit about that workflow, and I've described it, but here I have it captured on a slide, and you'll all get it in the proceedings of the session, right? But what we're seeing people do is really baseline the utilization of the existing plant, profile and correlate those workloads to the plant, and then start using those predictive analytics to prescribe optimized sizing and predict outcomes to then get to the end result, which is really make more informed decisions as to what's going to move, what isn't, and what's going to get re-architected how. So the applicability, and we've talked about this a whole bunch, so I'm not going to spend time on these charts, but when you walk away with them, there's actually these wizards, if you will, or these scenario managers that focus on these different kind of scenarios, right? Whether it's a change of platform, i.e., we're all depreciating assets at 3 or 5 year cycles, right? So if I replace these boxes, how much more can I put on them? Even if I'm building a private cloud, right? I'm going to convert these assets to my own private cloud, and I'm going to, refresh 20% of them this year because they've fallen off my my depreciation schedule, right? Virtualization, app delivery changes, etc. And I try to align them to both what we're doing on the technology side versus what we're being asked by the lines of business to do, right? So both of those tend to be scenarios that drive this kind of need for analytics, if you will. And in that context, I wanted to just show some sample views of what people are doing. And it's a little bit washed out on this screen, unfortunately. But picture, if you will, the ability to understand in a data center, a landscape for a particular application, et cetera, in terms of profiling existing usage, the ability to say, I've got the gray line here, which is a little hard to see, is my total capacity available. The green is how much capacity I'm using, is profiling capacity, and you can see the high water mark and the average and my planning percentile. The idea here is back to what I was saying earlier, to normalize across different platforms and understand how much resource I'm consuming so that I clearly understand the 2B state, what I'm using right now, so I understand what I'm going to need in the 2B environment and how it's going to consume the resources in the 2B environment. So we've got some abilities around normalization. Some people, I know that there's some smart people out there that are doing it themselves with spreadsheets and spec-int numbers for all their different platforms, and creating the pivot table from hell to try to manage that. But we've got some automation around that space, for example.
So you run this software
On any platform.
on a platform
Yeah.
to do that
Yeah.
analysis.
The other part of it, and here's that resource score, right? So picture, if you will, you have a horsepower number assigned to each box. You have a model library, if you will, of all the different boxes, and the ability to then understand how much you're consuming and also what's over and underutilized. This is actually a really good snapshot of capacity consumption for an as-is environment. And this is another way to look at it, where you could see, bands of utilization, right? I'm going to call underutilized the blue, and it's, let's say it's 10 to 20, 20 to 40, et cetera. So here's a couple of interesting facts. You could do that for very large amounts of infrastructure. These are some of the reports that people love because you could get an entire data center on one graph in terms of how well am I using my stuff, right? But more importantly, you see the red here? Here's an example where we see, there's some machines running hot, and every time you add a step up here, it means somebody added capacity. So somebody bought more stuff, be it cloud, be it physical, be it virtual. Capacity was added here. But notice that the red didn't change. It's not uncommon. Back to the over-provisioning. Not only are we over-provisioning as a community, but we tend to over-provision in the wrong places. Here people added capacity and it didn't change what was running hot. The ability to look at things by service, right? So I can look at a particular business service, this was a website, and see how I'm doing currently and whether I have, just a time to live 3, 6, and 9 months out. How am I doing just with the existing trends, right? So these are very simple aggregations, if you will, based on just historical data and trending. Now, what we can overlay on top of that is the ability to then start looking at a lot more detail because of all these models, right? Here's these CPU scores, if you will, those horsepower scores for these different platforms, and then being able to correlate to the business service and how that server is being used. That's back to that profiling part I talked about. But once you have things profiled, and I'm running a little bit fast through this, is the ability to then, here's that relative sizing. The rectangle represents a total compute platform, the gray one. It's a little washed out, but picture gray rectangle, and then the blue is my peak utilization, my green is my average. You could see the boxes of the different sizes, so I could actually compare side by side, how much am I using of the A blades versus the B blades versus the C blades, to then do things that are more interesting, like take a cluster, an existing cluster, move it to a hypothetical cloud environment, or move it to hypothetical different hypervisor, different cloud provider, et cetera. So we've got models in the pull-down list for different hypervisors, different cloud providers, et cetera. And if you're building a private cloud, provide the ability to start modeling what the characteristics of your cloud are, if you will. And what that allows you to do then is to run these scenarios where as a cloud consumer or cloud provider, you can actually reserve capacity and understand how much resource you need just for moving these apps or these boxes into that infrastructure. More importantly then is being able to compare, for example, resource utilization and even cost. So we've got the ability to provide, if you tell me that your cost per compute unit is this much for your private cloud, this much for your physical assets, and this much is what you've negotiated with Verizon Terramark, you could actually trade off how much it's going to cost you to go to a certain landscape rather quickly. So that cost balancing as well. Whether you reserve it, it's new, reassigned, resized, and changed, create a map of how you're managing that capacity. And more importantly, back to the description earlier about response times versus payloads, is the ability to say, as my transaction arrival rate increases, what's going to happen to my response time, right? Being able to take the historical metrics from an application performance management perspective and then project them out forward to the future to understand what will happen as the workload demand grows, for example, especially if it's going to be nonlinear versus historical metrics. So those are the kind of things that we see people doing out there that are becoming these enablers, if you will, to move more rapidly to the cloud beyond just these onesie twosies, a test platform or a non-critical service, if you will. I've got all kinds of different scenarios that are fairly self-explanatory in the charts, but the bottom line, in terms of winding down, is that we're seeing both consumers and providers seeing a lot of potential for the cloud. We're seeing edicts come from CFOs and policymakers, et cetera, that say, this is the way we're going, right? So while we're seeing that, at the same time, there's this big gap in terms of making people comfortable with moving the workloads there. So there's a gap in terms of what data is available, what tools and analytics are available to do that. And the biggest around the payloads themselves, the applications and the workloads. The standards are still evolving, right? You've got things like Tosca and Deep TMF trying to build some standards so that you could actually extract an open API of performance metrics from different clouds. But that's not there yet, right? So until that kind of stuff is there, and until the vendors choose to expose those metrics, all we can do is keep at it with some of the analysis approaches that were just covered today. And we're seeing quite a bit of success in the field with those kind of approaches. Obviously, it's an evolving and rapidly changing arena, but that's what we're seeing as sort of the state of the art right now in terms of enabling migration. Appreciate the attention today, and we'll open it up for a few minutes of Q&A here. Any questions? Sounds like the answer. Oh, yes, there is a question. Okay.
So if VMware has a lot of monitoring and data gathering
Sure.
and performance.
Absolutely.
Does the CA product
It would consume data from VMware, because what I would say about the VMware tools,
is it an add-on to it?
yeah,
or
it can
is
complement
just
it.
another-
It doesn't replace it. It adds on to it. And here's why. Because think about it like the early days of networking, right? You bought a whole bunch of Cisco gear, and you bought Cisco Works to manage your Cisco gear. Well, Cisco Works was really good at managing configuration, helping you deploy things, understanding how you're doing right here, right now, but it didn't have a lot of the bells and whistles that you needed for broader, longer term. It was very much operational, real-time kind of stuff. The other thing is it's very focused towards only VMware. So what we're seeing out there is that people need to migrate things to and from VMware, and that VMware is not necessarily the only answer to this cloud question, right? So as a result of that, we're seeing that people, VMware is a big part of it. They have tremendous market share. They build great tools as the element manager, if you will, and some tactical capacity views, but they don't have the predictive analytics, and they don't have the view of the rest of the infrastructure. So they'd become a feed of that. Remember I was saying agentless with performance data consumed? That's where the data would come from, or one of the sources of data.
For that particular, your application, does it, you have to run an agent on every one of your servers?
Absolutely not. We can not. It's agentless. We consume the performance data that's already in the environment. So if you're using VMware, we'll hook up to the vCenter database. If you're using Tivoli, we'll hook up to the Tivoli data source.
Have a unified computing system in Cisco.
Cisco UCS.
And
what do you manage?
have 200 other servers.
Sure. What are you managing them with?
All of them. Nothing right now.
Okay, so we have system management tools in our portfolio that could help you with that. There's a number of other vendors that have those. From the slice that I presented, we'd consume data from those system management tools regardless of where they are.
But the data you get,
yes.
you get it based off of a profile that you input into your application, or off of real-time management?
Off of the real, so picture, if you will, if you have Cisco UCS, right? So you have a series of UCS blades, and let's say you've got SNMP agents on them, and you've got some poller that is, every 5 minutes or every minute or however periodically, it's coming and pulling out, CPU, memory, et cetera. If you're running VMware on top of UCS, you probably have vCenter there.
Yeah.
And so you're collecting, how many VMs you have per cluster, what ESX hosts are running on what UCS blades, that sort of data. So all that gets aggregated. The piece that you need on top of that is at the process level or the application level if you want to get into that, right? So, fine, I've got a VM associated with customer XYZ. The next step is what payload is he or she running on it, and what's the throughput of it. So maybe you need some application performance monitoring and management tools, et cetera. There's some in our portfolio that, please come by our booth and you could talk about them, but in the context of what I put forth, you'd consume that data to then build the as-is model to then project growth, project impact, et cetera. Make sense?
Yeah. Thanks.
Appreciate your time. Thank you.